Chapter 5: Physiological Evidence of Mental Mastery. We have been considering the relationship between mind and body from the standpoint of the mind. Our investigation has been largely introspective. That is to say, we simply looked within ourselves and considered the effects of our mental operations upon our own bodies. The facts we had before us were facts of which we had direct knowledge. We did not have to go out and seek them in the mental and bodily activities of other persons. We found them here within ourselves, inherent in our consciousness. To observe them, we had merely to turn the spotlight into the hidden channels of our own minds. We come now to examine the mind's influence upon the body from the standpoint of the body. To do this, we must go forth and investigate. We must use eye, ear, and hand. We must use the forceps and scalpel and microscope of the anatomist and physiologist. But it is well worthwhile that we should do this, for our investigation will show a bodily structure peculiarly adapted to control by a governing consciousness. It will reveal to the eye a physical mechanism peculiarly fitted for the dissemination of intelligence throughout the body. And most of all, it will disclose the existence within the body of subordinate mental units, each capable of receiving, understanding, and acting upon the intelligence thus submitted. And we shall have strongly corroborative evidence of the mind's complete control over every function of the body. Examine a green plant, and you will observe that it is composed of numerous parts, each of which has some special function to perform. The roots absorb food and drink from the soil. The leaves breathe in carbonic acid from the air and transform it into the living substance of the plant. Every plant has, therefore, an anatomical structure, its parts and tissues visible to the naked eye. Put one of these tissues under a microscope, and you will find that it consists of a honeycomb of small compartments or units. These compartments are called cells, and the structure of all plant tissues is described as cellular. Wherever you may look in any plant, you will find these cells making up its tissues. The activity of any part or tissue of the plant, and consequently, all of the activities of the plant as a whole, are but the combined and cooperating activities of the various individual cells of which the tissues are composed. The living cell, therefore, is at the basis of all plant life. In the same way, if you turn to the structure of any animal, you will find that it is composed of parts or organs made up of different kinds of tissues, and these tissues, examined under a microscope, will disclose a cellular structure similar to that exhibited by the plant. Look where you will among living things, plant or animal, you will find that all are mere assemblages of cellular tissues. Extend your investigation further and examine into forms of life so minute that they can be seen only with the most powerful microscope, and you will come upon a whole universe of tiny creatures consisting of a single cell. Indeed, it is a demonstrable fact that these tiny units of life consisting of but a single cell are far more numerous than the forms of life visible to the naked eye. You will have some idea of their size and number when we tell you that millions may live and die and reproduce their kind in a single thimbleful of earth. Every plant, then, or every animal, whatever its species, however simple or complicated its structure, is in the last analysis either a single cell or a confederated group of cells. All life, whether it be the life of a single cell, or of an unorganized group of cells, or of a republic of cells, has as its basis the life of the cell. For all the animate world, two great principles stand established. First, that every living organism, plant or animal, big or little, develops from a cell, and is itself a composite of cells, and that the cell is the unit of all life. Secondly, that the big and complex organisms have through long ages developed out of simpler forms, the organic life of today being the result of an age long process of evolution. What then is the cell, and what part has it played in this process of evolution? To begin with, a cell is visible only through a microscope. A human blood cell is about 1/3000th of an inch across, while a bacterial cell may be no more than 1/25,000th of an inch in diameter. Yet, small as it is, the cell exhibits all of the customary phenomena of independent life. That is to say, it nourishes itself, it grows, it reproduces its kind, it moves about, and it feels. It is a living, breathing, feeling, moving, feeding thing. The term cell suggests a walled in enclosure. This is because it was originally supposed that a confining wall or membrane was an invariable and essential characteristic of cell structure. It is now known, however, that while such a membrane may exist, as it does in most plant cells, it may be lacking, as is the case in most animal cells. The only absolutely essential parts of the cell are the inner nucleus or kernel and the tiny mass of living jelly surrounding it, called the protoplasm. The most powerful microscopes disclose in this protoplasm a certain definite structure, a very fine, thread like network spreading from the nucleus throughout the semi fluid albuminous protoplasm. It is certainly in line with the broad analogies of life to suppose that in each cell, the nucleus with its network is the brain and nervous system of that individual cell. All living organisms consist, then, simply of cells. Those consisting of but one cell are termed unicellular. Those comprising more than one cell are called pluricellular. The unicellular organism is the unit of life on this earth. Yet tiny and ultimate as it is, every unicellular organism is possessed of an independent and free living existence. To be convinced of this fact, just consider for a moment the scope of development and range of activities of one of these tiny bodies. We see then, says Haeckel, that it performs all the essential life functions which the entire organism accomplishes. Every one of these little beings grows and feeds itself independently. It assimilates juices from without, absorbing them from the surrounding fluid. Each separate cell is also able to reproduce itself and to increase. This increase generally takes place by simple division, the nucleus parting first, by a contraction round its circumference, into two parts, after which the protoplasm likewise separates into two divisions. The single cell is able to move and creep about. From its outer surface, it sends out and draws back again finger like processes, thereby modifying its form. Finally, the young cell has feeling and is more or less sensitive. It performs certain movements on the application of chemical and mechanical irritants. The single cell moves about in search of food. When food is found, it is enveloped in the mass of protoplasm, digested, and assimilated. The single cell has the power of choice, for it refuses to eat what is unwholesome and extends itself mightily to reach that which is nourishing. Mobius and Gates are convinced that the single cell possesses memory, for having once encountered anything dangerous, it knows enough to avoid it when presented under similar circumstances. And having once found food in a certain place, it will afterwards make a business of looking for it in the same place. And finally, Verworn and Bennett have found in a single living cell manifestations of the emotions of surprise and fear, and the rudiments of an ability to adapt means to an end. Let us now consider pluricellular organisms and consider them particularly from the standpoint of organic evolution. The pluricellular organism is nothing more nor less than a later development, a confederated association of unicellular organisms. Mark the development of such an association. Originally, each separate cell performed all the functions of a separate life. The bonds that united it to its fellows were of the most transient character. Gradually, the necessities of environment led to a more and more permanent grouping, until at last the bonds of union became indissoluble. Meanwhile, the great laws of adaptation and heredity, the basic principles of evolution, have been steadily at work, and slowly there has come about a differentiation of cell function, an apportionment among the different cells of the different kinds of labor. As the result of such differentiation, the pluricellular organism, as it comes ultimately to be evolved, is composed of many different kinds of cells. Each has its special function, each has its field of labor, each lives its own individual life, each reproduces its own kind, yet all are bound together as elements of the same cell society or organized cell state. Among pluricellular organisms, man is of course supreme. He is the one form of animal life that is most highly differentiated. Knowing what you now know of microscopic anatomy, you cannot hold to the simple idea that the human body is a single life unit. This is the naive belief that is everywhere current among men today. Inquire among your own friends and acquaintances, and you will find that not one in 1,000 realizes that he is, to put it jocularly, singularly plural, that he is in fact an assemblage of individuals. Not only is the living human body as a whole alive, but every part of it, as large as a pinpoint, is alive, with a separate and independent life all its own. Every part of the brain, lungs, heart, muscles, fat, and skin. No man ever has or ever can count the number of these parts or cells, some of which are so minute that it would take thousands in a row to reach an inch. Feeling or consciousness is the sum total of the feelings and consciousness of millions of cells, just as an orchestral harmony is a composite of the sounds of all the individual instruments. In the ancient dawn of evolution, all the cells of the human body were of the same kind. But nature is everywhere working out problems of economy and efficiency. And, to meet the necessities of environment, there has gradually come about a parceling out among the different cells of the various tasks that all had been previously called upon to perform for the support of the human institution. This differentiation in kinds of work has gradually brought about corresponding and appropriate changes of structure in the cells themselves, whereby each has become better fitted to perform its part in the sustenance and growth of the body. When you come to think that these processes of adaptation and heredity in the human body have been going on for countless millions of years, you can readily understand how it is that the human body of today is made up of more than 30 different kinds of cells, each having its special function. We have muscle cells with long, thin bodies like pea pods who devote their lives to the business of contraction. Thin, hair like connective tissue cells whose office is to form a tough tissue for binding the parts of the body together. Bone cells, a trace union of masons, whose life work it is to select and assimilate salts of lime for the upkeep of the joints and framework. Hair, skin, and nail cells in various shapes and sizes, all devoting themselves to the protection and ornamentation of the body. Gland cells, who give their lives, a force of trained chemists, to the abstraction from the blood of those substances that are needed for digestion. Blood cells, crowding their way through the arteries, some making regular deliveries of provisions to the other tenants, some soldierly fellows patrolling their beats to repel invading disease germs, some serving as humble scavengers. Liver cells engaged in the menial service of living off the waste of other organs and at the same time converting it into such fluids as are required for digestion. Windpipe and lung cells, whose heads are covered with stiff hairs, which the cell throughout its life waves incessantly to and fro. And, lastly, and most important and of greatest interest to us, brain and nerve cells. The brain cells constituting altogether the organ of objective intelligence, the instrument through which we are conscious of the external world, and the nerve cells swerving as a living telegraph to relay information from one part of the body to another with the swiftness of thought. Says one writer, referring to the cells of the inner or true skin. As we look at them arranged there like a row of bricks, let us remember two things. First, that this row is actually in our skin at this moment. And, secondly, that each cell is a living being. It is born, grows, lives, breathes, eats, works, decays, and dies. A gay time of it, these youngsters have on the very banks of a stream that is bringing down to them every minute stores of fresh air in the round, red corpuscles of the blood, and a constant stream of suitable food in the serum. But it is not all pleasure, for every one of them is hard at work. And again, speaking of the cells that line the air tubes, he says, the whole interior, then, of the air tubes resembles nothing so much as a field of corn swayed by the wind to and fro. The principal sweep, however, being always upwards towards the throat. All particles of dust and dirt inhaled drop on this waving forest of hairs and are gently passed up and from one to another out of the lungs. When we remember that these hairs commenced waving at our birth and have never for 1 second ceased since, and will continue to wave a short time after our death, we are once more filled with wonder at the marvels that surround us on every side. Remarkable confirmatory evidence of the fact that every organ of the body is composed of individual cell intelligences, endowed with an instinctive knowledge of how to perform their special functions, is found in the experiments of Dr. Alexis Carrel, the recipient of the Nobel Prize for Science for 1912. Dr. Carrel has taken hearts, stomachs, and kidneys out of living animals, and by artificial nourishment has succeeded in keeping them steadily at work digesting foods, and so on, in his laboratory for months after the death of the bodies from which they were originally taken. We see then that every human body is an exceedingly complex association of units. It is a marvelously correlated and organized community of countless microscopic organisms. It is a sort of cell republic, as to which we may truthfully paraphrase life and union, one and inseparable. Every human body is thus made up of countless cellular intelligences, each of which instinctively utilizes ways and means for the performance of its special functions and the reproduction of its kind. These cell intelligences carry on, without the knowledge or volition of our central consciousness, that is to say, subconsciously, the vital operations of the body. Under normal conditions, conditions of health, each cell does its work without regard to the operations of its neighbors. But in the event of accident or disease, it is called upon to repair the organism. And in this, it shows an energy and intelligence that savor of creative power. With what promptness and vigor the cells apply themselves to heal a cut or mend a broken bone. In such cases, all that the physician can do is to establish outward conditions that will favor the cooperative labors of these tiny intelligences. The conclusion to be drawn from all this is obvious. For, if every individual and ultimate part of the body is a mind organism, it is very apparent that the body as a whole is peculiarly adapted to control and direction by mental influences. Do not lose sight of the fact that improving such control, we are laying the foundation for a scientific method of achieving practical success in life, since all human achievement comes about through some form of bodily activity. We assume now your complete acceptance of the following propositions, based as they are upon facts long since discovered and enunciated in standard scientific works. A. The whole body is composed of cells, each of which is an intelligent entity endowed with mental powers commensurate with its needs. B. The fact that every cell in the body is a mind cell shows that the body, by the very nature of its component parts, is peculiarly susceptible to mental influence and control. To these propositions, we now append the following. C. A further examination of the body reveals a central mental organism, the brain, composed of highly differentiated cells whose intelligence, as in the case of other cells, is commensurate with their functions. D. It reveals also a physical mechanism, the nervous system, peculiarly adapted to the communication of intelligence between the central governing intelligence and the subordinate cells. E. The existence of this mind organism and this mechanism of intercommunication is additional evidence of the control and direction of bodily activities by mental energy. The facts to follow will not only demonstrate the truth of these propositions, but will disclose the existence within every one of us of a store of mental energies and activities of which we are entirely unconscious. The brain constitutes the organ of central governing intelligence, and the nerves are the physical means employed in bodily intercommunication. Brain and nerves are, in other words, the physical mechanism employed by the mind to dominate the body. Single nerve fibers are fine, thread like cells. They are so small as to be invisible to the naked eye. Some of them are so minute that it would take 20,000 of them laid side by side to measure an inch. Every nerve fiber in the human body forms one of a series of connecting links between some central nerve cell in the brain or spinal cord on the one hand and some bodily tissue on the other. All nerves originating in the brain may be divided into two classes, according as they carry currents to the brain or from it. Those carrying currents to the brain are called sensory nerves, or nerves of sensation. Those carrying currents from the brain are called motor nerves, or nerves of motion. Among the sensory nerves are the nerves of consciousness, that is, the nerves whereby we receive sense impressions from the external world. These include the nerves of touch, sight, pain, hearing, temperature, taste, and smell. Motor nerves are those that carry messages from the brain and spinal cord on the one hand to the muscles on the other. They are the lines along which flash all orders resulting in bodily movements. Another broad division of nerves is into two great nerve systems. There are the cerebrospinal system and the sympathetic system. The first, the cerebrospinal system, includes all the nerves of consciousness and of voluntary action. It includes all nerves running between the brain and spinal cord on the one hand and the voluntary muscles on the other. The second, the sympathetic nerve system, consists of all the nerves of the unconscious or functional life. It therefore includes all nerves running between the brain and sympathetic or involuntary nerve centers on the one hand and the involuntary muscles on the other. Every bodily movement or function that you can start or stop at will, even to such seemingly unconscious acts as winking, walking, etc., is controlled through the cerebrospinal system. All other functions of the body, including the great vital processes, such as heart pulsation and digestion, are performed unconsciously, are beyond the direct control of the will, and are governed through the sympathetic nerve system. It is obvious that the cerebrospinal nerve system is the organ of consciousness, the apparatus through which the mind exercises its conscious and voluntary control over certain functions of the body. It is equally obvious that the sympathetic system is not under the immediate control of consciousness, is not subject to the will, but is dominated by mental influences that act without, or even contrary to, our conscious will, and sometimes without our knowledge. Yet you are not to understand that these two great nerve systems are entirely distinct in their operations. On the contrary, they are in many respects, closely related. Thus, the heart receives nerves from both centers of government, and besides all this, is itself the center of groups of nerve cells. The power by which it beats arises from a ganglionic center within the heart itself, so that the heart will continue to beat apart from the body if it be supplied with fresh blood. But the rapidity of the heart's beating is regulated by the cerebrospinal and sympathetic systems, of which the former tends to retard the beat and the latter tends to accelerate it. In the same way, your lungs are governed in part by both centers, for you can breathe slowly or rapidly as you will, but you cannot, by any power of conscious will, stop breathing altogether. Your interest in the brain and nerve system is confined to such facts as may prove to be of use to you in your study of the mind. These anatomical divisions interest you only as they are identified with conscious mental action on the one hand and unconscious mental action on the other. It is therefore of no use to you to consider the various divisions of the sympathetic nerve system, since the sympathetic nerve system in its entirety belongs to the field of unconscious mental action. It operates without our knowledge and without our will. The cerebrospinal system consists of the spinal cord and the brain. The brain, in turn, is made up of two principal subdivisions. First, there is the greater or upper brain called the cerebrum. Secondly, there is the lower or smaller brain called the cerebellum. The cerebrum, in turn, consists of three parts: the convoluted surface brain, the middle brain, and the lower brain. So that in all we have the surface brain, the middle brain, the lower brain, and the cerebellum. All these parts consist of masses of brain cells with connecting nerve fibers. And now, as to the functions of these various parts. Beginning at the lowest one and moving upward, we find first that the spinal cord consists of through lines of nerves running between the brain and the rest of the body. At the same time, it contains within itself certain nerve centers that are sufficient for many simple bodily movements. These bodily movements are such as are instinctive or habitual, and require no distinct act of the will for their performance. They are mere reactions, without conscious, volitional impulse. Moving up one step higher, we find that the cerebellum is the organ of equilibrium, and that it, as well as the spinal cord, operates independently of the conscious will, for no conscious effort of the will is required to make one reel from dizziness. As to the divisions of the greater brain or cerebrum, we want you to know that the lower brain serves a double purpose. First, it is the channel through which pass through lines of communication to and from the upper brain and the midbrain on the one hand, and the rest of the body on the other. Secondly, it is itself a central office for the maintenance of certain vital functions, such as lung breathing, heart beating, saliva secreting, swallowing, etc., all involuntary and unconscious in the sense that consciousness is not necessary to their performance. The next higher division or midbrain is a large region from which the conscious will issues its edicts regulating all voluntary bodily movements. It is also the seat of certain special senses such as sight. Lastly, the surface brain, known as the cortex, is the interpretative and reflective center, the abode of memory, intellect, and will. The functions of these various parts are well illustrated by the effects of alcohol upon the mind. If a man takes too much alcohol, its first apparent effect will be to paralyze the higher or cortical center. This leaves the midbrain without the check brain of a reflective intellect, and the man will be senselessly hilarious or quarrelsome, jolly or dejected, pugnacious or tearful, and would be ordinarily described as drunk. If in spite of this he keeps on drinking, the midbrain soon becomes deadened and ceases to respond, and the cerebellum, the organ of equilibrium, also becomes paralyzed. All voluntary bodily movements must then cease, and he rolls under the table, helpless and dead drunk, or in language that is even more graphically appreciative of the physiological effects of alcohol, paralyzed. However, the deep seated sympathetic system is still alive. No assault has yet been made upon the vital organs of the body. The heart continues to beat and the lungs to breathe. But suppose that some playful comrade pours still more liquor down the victim's throat. The medulla, or lower brain, then becomes paralyzed. The vital organs cease to act, and the man is no longer dead drunk. He has become a sacrifice to Bacchus. He is literally and actually dead. It seems then that the surface brain and midbrain constitute together the organ of consciousness and will. Consciousness and will disappear with the deadening or paralysis of these two organs. Yet these two organs constitute but a small proportion of the entire mass of brain and nervous tissue of the body. In addition to these, there are not only the lower brain and the spinal cord and the countless ramifications of motor and sensory nerves throughout the body, but there are also separate nerve centers or ganglia in every one of the visceral organs of the body. These ganglia have the power to maintain movements in their respective organs. They may in fact be looked upon as little brains, developing nerve force and communicating it to the organs. All these automatic parts of the bodily mechanism are dominated by departments of the mind entirely distinct from ordinary consciousness. In fact, ordinary consciousness has no knowledge of their existence excepting what is learned from outward bodily manifestations. All these different organic ganglia constitute together the sympathetic nerve system, organ of that part of the mind which directs the vital operations of the body in apparent independence of the intelligence commonly called the mind, an intelligence which acts through the cerebrospinal system. Yet this independence is far from being absolute, for as we have seen, not only is the cerebrospinal system, which is the organ of consciousness, the abode of all the special senses, such as sight, hearing, etc., and therefore our only source of information of the external world, but many organs of the body are under the joint control of both systems. So it comes about that these individual intelligences governing different organs of the body, with their intercommunications, are dependent upon consciousness for their knowledge of such facts of the outer world as have a bearing on their individual operations, and they are subject to the influence of consciousness as the medium that interprets these facts. It is unnecessary for us to go into this matter deeply. It is enough if you clearly understand that, in addition to consciousness, the department of mind that knows and directly deals with the facts of the outer world, there is also a deep seated and seemingly unconscious department of mind consisting of individual organic intelligences capable of receiving, understanding, and acting upon such information as consciousness transmits. We have spoken of conscious and seemingly unconscious departments of the mind. In doing so, we have used the word seemingly advisedly. Obviously, we have no right to apply the term unconscious without qualification to an intelligent mentality such as we have described. Unconscious simply means not conscious. In its common acceptation, it denotes, in fact, an absence of all mental action. It is in no sense descriptive, it is merely negative. Death is unconscious, but unconsciousness is no attribute of a mental state that is living and impellent and constantly manifests its active energy and power in the maintenance of the vital functions of the body. Hereafter, then, we shall continue to use the term consciousness as descriptive of that part of our mentality which constitutes what is commonly known as the mind, while that mental force, which, so far as our animal life is concerned, operates through the sympathetic nerve system, we shall hereafter describe as subconscious. Let us summarize our study of man's physical organism. We have learned that the human body is a confederation of various groups of living cells, that in the earliest stages of man's evolution, these cells were all of the same general type, that as such they were free living, free thinking, and intelligent organisms as certainly as were those unicellular organisms which had not become members of any group or association. that through the processes of evolution, heredity, and adaptation, there has come about in the course of the ages a subdivision of labor among the cells of our bodies and a consequent differentiation in kind, whereby each has become peculiarly fitted for the performance of its allotted functions. That, nevertheless, these cells of the human body are still free living, intelligent organisms, of which each is endowed with the inherited, instinctive knowledge of all that is essential to the preservation of its own life and the perpetuation of its species within the living body. That, as a part of the specializing economy of the body, there have been evolved brain and nerve cells performing a twofold service. First, constituting the organ of a central governing intelligence with the important business of receiving, classifying, and recording all impressions or messages received through the senses from the outer world. And, second, communicating to the other cells of the body such part of the information so derived as may be appropriate to the functions of each. That finally, as such complex and confederated individuals, each of us possesses a direct, self conscious knowledge of only a small part of his entire mental equipment. That we have not only a consciousness receiving sense impressions and issuing motor impulses through the cerebrospinal nervous system, but that we have also a subconsciousness manifesting itself, so far as bodily functions are concerned, in the activity of the vital organs through the sympathetic nerve system. That this subconsciousness is dependent on consciousness for all knowledge of the external world. That, in accordance with the principles of evolution, man as a whole and as a collection of cell organisms, both consciously and unconsciously, is seeking to adapt himself to his external world, his environment, that the human body, both as a whole and as an aggregate of cellular intelligences, is therefore subject in every part and in every function to the influence of the special senses and of the mind of consciousness.